Yes, Kirti, any question?
Yeah, am I audible?
Yeah, you are audible. Yes, go ahead.
Okay, sir. So I have a doubt in that polyparamagnetism and Curie paramagnetism.
Yes, yes.
Is there any materials both that they can show both these properties together?
Yes, in some sense, they show the Yeah, am I audible now? Sunita, can you hear me? Okay. Yeah. Okay, you are facing. Okay, all right. No problem. So, yes, I mean, basically, it's one is due to the Pauli paramagnetism is due to your completely free electron, then the other is for unfilled shell. So a material can show these properties, but it's very difficult to, separate one property from another. And if you are saying that some materials which will have both these things, then a constant term plus 1 over t would simply look like 1 over t, because that constant term won't really show up in any experiment, or it will, even if it shows up, really it won't be perceptible. So yes, in principle it does. It shows up in metals which are not, normal metals which are not very good. But yes, the but in those cases you have both a constant term which are coming from the free electrons and 1 over t behavior which is coming from the Curie type, which are unfilled shells.
Okay, sir. Got it. That.
Yeah. Okay. If there is any question for other people who are watching, or even Kirti, you could ask.
Sir, I have one more question.
Please,
Uh,
please.
yeah. The the white dwarfs are made up of fermions, right? So they're white dwarfs, white dwarfs.
White dwarfs are, yes,
Yeah.
yes, yes. So white dwarfs are basically the used up, completely used up nuclei. And these nuclei are basically nothing but the ionized helium atoms. So they are, a very large number of degenerate Fermi gas. Okay, so yeah, so that is what it is. So there are large number of electrons that are in highly degenerate state at low temperature.
Mhm. Yeah.
You
So
can go
here
ahead.
the gravitational pressure is opposed by the degeneracy pressure, right?
Yes, by the fermionic pressure. Yes,
Yeah.
by the
But
pressure given by the fermions, which,
yeah.
as we have shown in the class, that itself is very large, right? The pressure per
Mhm.
particle goes as some 3 by
Yeah.
5 epsilon f. So these internal pressure due to the fermions, they try to oppose the gravitational collapse. So there is a competition between the two, and one lands up getting a sort of, when these competition one takes over the other, then there's a collapse. That's what is done.
Okay. So if bosons are the constituent particles for a star, then what would be the pressure which is opposing the gravitational attraction?
Good question. So bosons, even when they are in the same energy state, the if you look at my BEC notes, it says that it's only half of the atmospheric pressure, which is extremely less. Like we all have an atmospheric pressure on our head, but we never feel it, right? So if they are instead of fermions, they are bosons, they would have just collapsed right there without any resistance from inside. So bosons are like that because of the exclusion principle. Fermions are extremely, they give pressure to the, or they provide pressure in some kind of a container that you have kept them in, whereas the bosons almost provide no pressure.
Okay, sir. Yeah, got it.
Yeah. You can ask me some further questions if you have. So this was from the Fermi statistics, and then we have also done some, these special topics which are where statistical mechanics is applicable. These are not usually done in any book, but some of these things I thought that maybe they are useful for you to learn some specialized topics. For example, cluster expansion, etc. There in Patria, but rarely, it is taught at the master's level, and so it's not really well taught in universities and in other institutes. So I thought it will be good to give that perspective. Please ask if there's any question. You can write in the chat box for the people who are watching in YouTube. It's only limited to 1 hour and this is the last interaction session. If anyone is watching in YouTube, you may ask question, type the question, I'll answer them. Sunita will close it at 3:30. I don't think you Queenie, and she asked her a few questions and then she left, which is fine. Yeah, yeah, sure. कुछ कोई कुछ रहने से then I can say that what the course is all about, but कोई है ही नहीं. 3:30 में stop कर. Yeah, yeah, yeah. For the people who are watching in YouTube, I see a number of people joining now. Please do ask questions. You can type on the box that's there. If anyone is watching on the YouTube, please do ask me questions if you have any doubt, you want to know anything, if there is any confusion, anything. Tell me. Yeah, we can wind up. कोई question भी नहीं है, कोई देख भी नहीं रहा है. So I think there is no point in wasting our time. I don't know why, because this course is is quite an important course for physics all across. और उसमें there are no books which are self-sufficient. So I don't know. Maybe it's that इस time शायद college में होंगे. So that could be the reason. हाँ हाँ हाँ. Y- yes. Just let me. Yeah, it's 3:30. Okay, so this attendance has been very poor. I don't know why people didn't attend, but probably they're busy. I would still be available for asking questions, but do ask conceptual questions and think about it before you ask questions. So with this, we are closing down this interaction session. It was the third one and the last one, and hope you do well in the final exams. Okay. All right. Thank you. Thank you, Sunita.